All right, I'm Caleb Wilson. I teach eighth grade science at Stephen Decatur Middle School.
And I am Kyle Wheatley. I teach with Caleb eighth grade science as well at Stephen Decatur.
And we were asked to, actually honored to get to presenting. We were asked to share a lesson that we did. We did a 5-minute tech session a couple of weeks ago, and we were asked to kind of like expound upon that lesson that we did to kind of show off some of the ways that we've been using technology in our classroom to kind of enhance our lessons and kind of give our students an opportunity to kind of express themselves as well in a different way. So give you the context and kind of set the stage for our unit. So this activity is called From Space to Earth, and it focused on meteor craters, impact craters versus volcanic craters. So currently in eighth grade science at Stephen Decatur Middle School, we're using the Stanford scale units. They are designed by Stanford Universities, specifically their Center for Assessment and Learning and Equity. And the unit that we're starting with is colossal collisions. And the whole idea of the unit is to answer the big question: what are the effects of asteroid collisions and how can we prevent future ones from happening?
And the cool thing about these Stanford scales is they have the entire curriculum laid out for middle school students, and it goes from sixth grade to eighth grade, and they have them integrated so that you are using chemistry and biology and physics and physical science and all these intermingled within these lessons. And the number one thing is that they are next gen science aligned. So for example, this first unit for this lesson that we did was the MS-LS 4-1. So that's middle school life science 4-1 is their our standard for that. And that basically deals with analyzing patterns in the fossil record to see things such as evolutionary change and just see the change throughout the Earth's history. And within Next Gen Science Standards, if you're not familiar with that, they have 3 separate things. They have the DCIs, which are the disciplinary core ideas. That's the main content area. Then they have the science and engineering practices. These are the things that scientists actually do in lab. This is how they do their research, and that's what they're trying to get the students to really get their hands on. So for example, this one is analyzing and interpreting data. So in here we do a lot of analyzing different craters to determine our next thing, which is our cross-cutting concept, is the patterns. So those cross-cutting concepts are things that we can see across multiple different disciplines. So you can see, patterns are really important in chemistry, for example, to see how we can identify unknowns and known things with that. Caleb, do you want to do the ISTE?
Yeah, so we're going to touch on the ISTE standards. Basically, our the International Society for Technology and Education standards. We're going to hit on those towards the end, but basically the idea is including this technology, including tech into our lessons, it hits a lot of standards that we're trying to do. Like obviously we're hitting our content standards. We really want them to know the content. We really want to teach them skills involved in being a scientist. And we want to give them some ways of thinking that can kind of tie science together. But in addition to that, leveraging the technology also gives us the chance to give them some 21st century skills that we think they're going to need outside of our classrooms, to be, collaborative learners, to be able to construct knowledge, to be able to express themselves in different ways, and also to be able to leverage technology to communicate that information. So we're gonna really dive in and show you kind of what the lesson looks like, and then as a result, like how does these lessons, how does leveraging this technology give us some value added to our assignments. And we really didn't go out of our way to do a lot of this stuff. These are just some technology tools we had at hand. And one of the big things in next gen science, and one of the things that Mr. Wheatley or Kyle and I are really big on, is doing authentic science. The way that Stanford unit's written, it originally had them focusing on like coming up with a solution that isn't really practical. And what I mean by that is they were rolling marbles down a hill and having them like collide into pennies, and that was their asteroid, and the pennies represented the Earth. And we really wanted to show them like, hey, there is a group of people at NASA who do this. They look for asteroids, they try to prevent them from hitting Earth. And we wanted to stick with this idea, this entire unit, that everything that they're seeing is authentic, it's real. We wanted them to see real asteroids, wanted them to see real craters, and we wanted to give them an authentic learning experience. So our lesson task, this is just one snippet of the unit, was to give them the ability to identify the difference between impact craters and volcanic craters. And we started having them look at those on other planets first, which we're going to show you how we were able to do that. And the reason why is because in order to study asteroids on our planet and the effect that asteroids have had on Earth, they need to know the difference between an impact crater and a volcanic crater, because both of them look very similar. They have some similar properties. And we wanted them to study the correct thing, because Earth has a history of getting hit by asteroids, but Earth also has a geological history of volcanoes. So we wanted them to study the right holes in the ground, basically. So basically what we had to do, and if Kyle, you want to jump in whenever to this, we started off by having a little bit of a class discussion by showing them two images of two different types of craters. And basically we had them collaborate together and look at these two images and just list some characteristics. What do you see in these images? What are the differences between these two images? What are the characteristics you see in each one specifically? And we started off by showing them just the images, and we wanted to start come up with what are the characters that define a volcanic crater? What are the characteristics that define an impact crater? And we had to explain to them these are top-down views, so we had to give them some context clues in terms of what to look for, because we told them that, hey, you're going to look at these craters on other planets first, and a lot of times we have satellite views that are looking down. So you have to analyze that data like a scientist would. You have to have that context and think like a scientist. What would this look like on the ground level, so to speak, if you were standing next to it, and what characteristics would you see?
And I do want to point out that we didn't make this. All of this, or a vast majority of this, is already out there. So this one is actually from BeringerCrater.com. So there is a Beringer crater out west of the U.S. Where it is an impact crater. And this lesson was developed by them, and we've modified it to our needs. But as Caleb said, the main thing is identifying the patterns and identifying the characteristics of known substances, or known, in this case, known geological instances in here, and then identifying which one would be which. And then we're going to look at some unknown and decide based on their characteristics, putting the pieces together and deciding, okay, this is a, it's raised up off the ground. So that would be a volcanic crater based on what's going on here.
And one of the things we had a conversation with the students about, which obviously Colin, I think this is extremely important, is the fact that yes, you're going to learn about volcanic craters, but we also want to think about the process that's involved. We're going to look and analyze data. We're going to analyze some images, because we talk about in science, data can be multiple different things. We could be looking at images, graphs, charts. We could be looking at observations, lab experiments, but we want to make sure we analyze the data and pull out the important information. And then based on that data, use patterns to start recognizing similarities, like Kyle just mentioned, in unknown craters that we were going to show them. So Kyle, you found these, so I'll bring up the different craters.
Perfect.
There we go. Sort of. Let me get back to where we're supposed to be. And all right, here we go.
Yep, click on that first link. Okay, so this is really cool. Everybody knows about Google Maps. Everyone knows about Google Earth. What they don't know is that Google has also put together maps of both Mars and the moon. So Caleb, go over to the next one. Go to Olympus Mons. I think it's to the left, or Mars Crater 2.
Oh,
nope, not
maybe it's not. Sorry, I'll just scroll over because I know what you're talking about.
Okay, so this picture here, this is actually the largest, the one Caleb zooming in on right now. This is the largest volcano in the galaxy. So this, I believe it is the size of Arizona. And this is the one that we had them look at on the picture. This is a very, very obviously raised above the ground. So it's going to have the characteristics of a volcanic crater. And from that, when we get to our next unit, we can say that Mars did have volcanic activity at one point, because that's how that has to form. And we can get the students to actually look at this and see the colors and see the actual elevations between the actual crater, which is in the center there, as well as the ground nearby. So we can show them that this is raised, what is that, 21 kilometers, Caleb? So that is I mean, that is huge. That's 17 miles.
21 kilometers to miles.
It's 13.05.
13 miles high.
13 miles high. And as I said, the size of it is the size of Arizona. So this one is a very typical volcanic crater. Caleb, can you find me an impact crater? Perfect. So as you guys can see, on the inside of this is pushed in, where then we have a ring around it, which is a typical crater characteristic. So because we can see these on another planet, we can say, okay, this is very obviously getting hit by asteroids, which will lead us into our next thing. Do you want to go to the moon?
Yeah, sorry, everything paused for a second. I was freaking out. Yeah, let me jump to the moon. So one of the benefits of doing this, we could have easily just given them pictures. And in the original lesson we found, it was just showing them images. But one of the things I've been switching through as Kyle's been explaining is the different options you have up here at the top left corner of elevation, in terms of what is it, an infrared picture versus a visible picture, which for us is kind of like value added in the sense that in the future units we're going to be getting to, we are going to be talking about the James Webb Telescope and the Hubble Telescope and how they take pictures using different types of light. So we've been explaining to them like, hey, we may not know what infrared light is yet or what visible light is yet. Well, hopefully they know what visible light is, but we're going to talk about that in the future. So we mention those things and we give them these tools like, hey, look at the elevation. Like, how does this help us see something different that visible light didn't? And yeah, we could have easily printed out like all these pictures or put them in Schoology or put them in our learning management system and given them, but this gives them the ability to interact with it. They can zoom in, they can zoom out, they can look at, the area around, they can, look at even more craters, but it gives us a little bit more interactivity, but also gives them the chance to have some inquiry involved in this and explore. Obviously we can't take them to the moon or take them to Mars, but this literally puts it at their fingertips, using regardless of what device you have. They could do this on, these are just links basically. They could do this on an iPad, they could do this on a Chromebook, they could do this on a computer, they could do it on a cell phone. And it's just more engaging and more authentic than hey, Mr. Wilson, I'm just going to look at these pictures, because that's what we've traditionally been doing in the past. So sorry, Kyle, I'll let you continue.
No, you're good. So that authentic that Caleb said is really, I mean, this could be very easily the next, viral TikTok trend, is looking at these things. Somebody pulls it up and makes a meme out of it, and that's all over the place. And kids are actually doing that right now. I mean, unfortunately, they learn things they probably shouldn't and might not be right, but this is authentic. They could click a link and go straight to this and just look around. To us, I mean, it's kind of mind-bending that they've mapped the moon, they've mapped Mars, and we can see it with our own eyes and actually do some inquiry with it. So on the moon, all we have pretty much are going to be those impact craters. So we can see those characteristics, and they can compare those to the ones that they saw both in the sheet that Caleb showed you, as well as the ones that we saw on the moon, on Mars. And then next up, Caleb's going to take us back to Earth. And from there, we can use the information that we got from Mars and the moon to identify craters and use the patterns and the characteristics that we saw on that to identify whether those things were created by volcanic activity or created by an extraterrestrial impact, really.
And kind of where we're headed, where we're headed with this is we want them to be familiar with these types of craters, because we want to study them on Earth. We want to study their effects on Earth. So first we're looking at other planets and looking at like, hey, what are the similarities between our planet and Mars, for example? Like, we both have geological processes that create volcanoes, but we also both get hit by asteroids. So we were giving them this information, kind of, I don't want to say front loading, but preparing them to start looking at impacts on Earth. And that's where our next two apps come from. And I'm on an iPad, but you can access Google Earth through a browser. You can access it through, if you have a smartphone, obviously you can download that app. If you have an iPhone or an app, iPad, you can use Maps. But I'm going to show you what it looks like in either one. So regardless of what device you're using, you can use whatever your flavor is. There are benefits to one over the other and vice versa. The ability for Maps, for example, is the ability to drop your own pins. You probably can do this in Google Earth, but I'm an Apple guy right now because our county is been, fortunate to give us iPads, so that's where I'm at. But for example, what we had them do is start to look at some different craters on the Earth, and we gave them some pins. So for example, this is the Barringer crater. Doesn't look like much right now. Let me move some stuff out of our way. But if we zoom out, we have a top-down view of the Barringer crater in Arizona. Now, the best part about using either Google Maps or Google Earth or Apple Maps is the ability to hit 3D. And this is where it starts to blow my mind. I hope the kids were excited about it, but I was stoked. So if you hit 3D, it actually gives you a 3D scan of the area. And they can zoom in on it. They can actually get really close. I mean, they can get all the way, basically right up on top of the building. Obviously, we don't care about the building. We care about the crater. But they can start to look at the crater now. They can navigate around it. They can move down inside of it and zoom in. And once again, all we're asking them to do is, hey, this pin that I dropped, what type of crater is this? And they'd say, hey, this is, well, it says meteor crater. I probably should label the pin something else. But they can see that it's a meteor crater, and they can start applying what they've learned looking at the other planets, the other craters on other planets, to say, hey, yeah, this has some of those same features. I recognize these repeatable patterns, raised edges of ejecta, the craters lower than the land around it. And they start to understand that, like, hey, these patterns repeat themselves. And this is how science actually classify living things. They classify, obviously, craters. And then we can start to have those conversations like, hey, well, if Mars gets hit by asteroids, the Earth is also getting hit by asteroids. So we can study other planets to learn more about our own planet. We can start having those conversations. So just to give you a couple of other examples of some pins. Oh no, I've lost pins. These are golf courses. That's probably not what I wanted to look up. I've lost my, oh, there we go. Got them back. All right. So this is another cool one that I found later on. This is actually right near I guess there's another volcano in Peru that's going off right now, I think. But this was the first volcano that started going off this year, was right down here, actually. But in trying to search for that and trying to see a live video of it erupting, I actually found this volcanic crater, which is absolutely massive. But once again, giving them the ability to look at this crater now and tell me, hey, what kind of crater is this based on what we've learned? Apply those patterns, look at those features, and what do you see happening? What do you see, is indicative that this is a volcanic crater versus an impact crater? And they can, look around, they can zoom in, zoom out. We'll talk about like what we actually had them do as their essentially their culminating project, our formative assessment, so to speak, to make sure they got this information. I'm going to do one more in Apple Maps, and then I'll jump over to Google Earth. So this is the Koko crater in Honolulu, Hawaii. I would love to go here because this looks absolutely awesome.
I think Brian Cook said he's going to send us there for research.
Yeah, I think the next MSET presentation is from here, right?
Yeah, right there. You right next to that pin. We're gonna house everybody. Don't worry. Bring your tent.
There we go. So yeah, it's just a really cool option to kind of show them these locations and let them interact with them in a different way. So let me jump over to Google Earth. I like the way Google Earth animates this way better than Apple does. So if I hit my search bar, I can go to my more recent one. So we'll go back to the Koko crater real quick, and this is so cool. Just zooms you right there. It's same location, looks a little different. You can get into 3D mode just by like manipulating. You don't have to actually hit a button. So we're there. And same kind of view, same kind of location object there. We have, where's the other place? Wolf Creek meteorite in Australia. So once again, it zooms us all out, zooms us back in. We'll talk about why that might be a cool feature in a second here. So once again, not as 3D. I'm not sure how many satellites fly over this location in Australia, but once again, we still have the ability to look at it, kind of from a different angle as opposed to top down. And then we'll fly to one more.
You can still see the patterns in that, even though it's not quite as animated as the other craters that he's shown. And just because we're using this with science, you can use this with really any of your curriculum. So if you're studying a battlefield in the Civil War, you could very, very, very easily drop pins. So for example, we're very close to Antietam. You could drop pins for all of the different things in there. You could drop pins for Burnside Bridge. You can drop pins for all of the specific sections in there and have the students go and take a peek at it, what it looks like now, and then maybe have a reading along with it.
So I wish I knew this, and Kyle, I love that you just brought that up, because in messing around with Google Earth, I actually found this, and Kyle, you know what I'm about to say in terms of scale, proportion, and quantity. We talk about the size of objects in our solar system, the size of objects in our universe, the size of objects on the ground. It's hard to put that in perspective for students, like the fact that they think the moon's really close, but it's really not that close.
And the
in
same
terms
size of
scale.
Earth as Earth.
Yeah. So Google Earth, and I didn't know this until I was playing around with it before our presentation, has a feature to do measurements. So I can, and this is the first time I'm trying this, so bear with me, but I can drop some measurements, add point. We'll put one here. Maybe I'm doing this wrong. I don't know, but we can add some points. Oh, there it is. I see it. We can add points, and they can measure the diameter of these craters. They can start to figure out how big these are, which informs us of how big the asteroid was that we're looking at. Because ultimately where we led them with this from this activity is after this, we had them look at the Chicxulub crater, the one that we believe, the one that we have scientific evidence to support that wiped out the dinosaurs. And now that we know the size of these craters, we can get an idea of the scale of that asteroid and how big it was and how much damage it did, and tie that to kinetic energy and impact force. And if you're a math teacher, you can start getting into the idea of diameter. You can start, hey, you're studying circles anyway. Hey, why don't we show them the diameter of an asteroid crater? Why don't we show them the diameter of something that's different than a circle I drew on the board or something like that? They can calculate circumference. They can calculate the area, volume, I believe, of the circle. Yeah, volume, absolutely. So once again, this doesn't have to be science. I know we come from a science standpoint because that's all we know, but we can start tying in the stuff. We could do history. We could drop pins for locations and learn about the history of these locations. So just really, really awesome things. I mean, I wish I'd known about this Google Earth like when we did the assignment. I mean, I'm learning myself because we could have had them measure all those things. We gave them a database that actually measured it for them, but we could have had them measure themselves, which would have been really cool. So what we had them do as their culminating activity, though, to prove that they learned this, was to either take a little video. They could screen record on the iPad and like show them navigating around one of these craters or two of these craters, or they could take a screenshot and they could mark it up. So Apple, our iPads give us the ability to do some markup and to write on the screen after we take a screenshot. But what we had them do is demonstrate their learning. Hey, take a picture of two different craters, an impact crater on Earth and an asteroid, a volcanic crater on Earth, and explain to us how you know the difference between the two. What are the characteristics that you identified in each of those craters that proves to us, Mr. Wheatley and I, that you understand what type of craters these are? Or hey, do a video, a flyover. I think there's a flyover button somewhere around here. Do a flyover and record the flyover in Google Earth as it flies around this location. Tell me what features are you seeing that makes this a volcanic crater compared to another location? So once again, just
with that markup tool, it's very easy to circle things. It's very easy to highlight things and draw an arrow to it. So they could take a screenshot. There you go, screenshot from different elevations and show this area is lower than this area, which indicates impact crater. Yes, perfect. So it's very easy, and they can submit that screenshot right to our learning management platform, which is Schoology, and they could submit that just as is, and it's extremely easy to grade, extremely easy to show their actual learning from this lesson.
So really, really, really awesome, activity that I'm patting myself on the back. Really awesome opportunity here to integrate some technology into this lesson. And we didn't really, like Kyle said, we found a lot of these resources that were already created. The Behringer Crater Company provided this activity. We just enhanced it with the technology tools that we had available. And as a result, we got some really cool outcomes that we really honestly, like Kyle and I didn't really realize, I'll say, until we actually had this conversation today in preparing this this presentation. So some of the outcomes, and Kyle, we can switch back and forth for these. Increased student engagement. I mean, how much cooler is this than just me giving you a stack of papers? How much cooler is it for you to be able to interact with these apps and these features and these programs to look at these locations, to go visit them, instead of just, hey, here it is up on the board, folks. Take a look at this, write down your information. Awesome, cool, let's move on.
Yep. And the student voice is big. You know, it's not everybody likes to do the video. They can take that screenshot and they can draw it up. I mean, they can draw their own. They could make you know, in the future we could also give them the opportunity of doing a Tinkercad like 3D design in there and showing an impact crater versus a volcanic crater. But we gave them choice in how they wanted to show us that they learned what we asked them to learn.
And once again, we're using real world science and data. This isn't something that we made up. These aren't fake craters. We didn't make them out of clay or something, which we could have done as well, which has been perfectly fine. But we're giving them authentic data, which it's much more powerful than us creating a fake narrative, you know, a fictitious narrative that they have to study from. This is real stuff. These are real locations on the earth. We have evidence that these places exist. We have pictures. We have proof. We started to look at the fossil record in terms of asteroid impacts. How do we have evidence that an asteroid hit in that location? It's authentic science that I think we don't do enough of in education. We don't put kids in control of doing real science. We do these workshop, you know, cookie cutter labs, and a lot of times we don't give them the opportunity to do some inquiry, do some real science like real scientists do it. And I think that's a huge one for us science folks.
Mm-hmm. Definitely deviate from the norm in that the labs were, I mean, kind of, hey, find an impact crater on Earth, find an impact crater on the moon, find a volcanic crater on Mars. What does that tell us, the volcanic crater on Mars, about what Mars used to be? That's a big thing, is that it actually shows the history of the planet and go from there. And also, why do we not have, it makes them ask those questions, why do we not have all these craters on Earth? Well, we have a living planet. We have a planet that has geological processes still. We have a planet that has the atmosphere. So it actually gets these students to buy into this and ask these questions that honestly should be asked by middle schoolers. It gets them to actually be engaged, and deviates from those norms where literally we just, okay, let's read this textbook.
And the amazing thing is those questions came organically. Like Kyle's not making this up. Like the students started to ask those questions. Like, wait a second. There's so many impact craters on the moon. There's so many impact craters on Mars, but we can't see that many on the Earth. Like we have to assume if there's that many on the moon, that the Earth got hit by just as many asteroids. So if that's the case, where's the evidence of that? Why can't we see all these craters? And then we start to get into conversations about geological processes. We've expanded the lesson beyond what the standards have asked us to do. And not that we're trying to go above and beyond, but we want our students to ask those questions. We want them to be inquisitive. We want them to be looking at this lesson from a different lens, from a different frame, and to, like I said, to ask those questions. If we get kids to start asking questions, our job's way easier, because we'd have to do less teaching. They're naturally engaged by asking their own questions and answering their own questions. So that to me is super powerful. And then in terms of the ISTE standards, ISTE provides a whole bunch of standards for students, for teachers, for administrators, and basically some of the ones that we hit on, and I don't want to say we planned this, because we definitely didn't. It was more just organic. It was part of the lesson. But students being empowered learners, leveraging technology to take a role in how they wanted to share what they've learned and pick up that knowledge. Being a knowledge creator, being able to use these different tools that we've shown them, using the science tools, the science skills, using the ways of thinking, using Google Maps, Google Earth, Google Mars, using maps from Apple, whatever those tools are, we put the tools in their hand and let them construct their knowledge. This is an inquiry assignment. We didn't say, hey, these are the characteristics you need to look for. This is why you need to look for them. Go on your scavenger hunt. We told them to come up with those ideas. We told them to make those connections. We told them to look for those patterns. And as a result, they used the technology to do that. And last but not least, being a creative communicator, using the technology to show us, to show Mr. Wheatley and I keep calling you Mr. Wheatley, to show Kyle and I what they learned. They had the option to do a video. They had the option to use their own voice in explaining their answers. They had the option to draw it, to write it, to annotate an image. And for some students, it's a lot easier if they're like, hey, Mr. Wilson, this is what I learned. If we had time to have a conversation with every kid after each class for them to tell us what they learned, I guarantee they'd be more successful. So why don't we give them the option to do that? Yeah, it'd make our job way easier, because at the end of the day, that's what we're trying to do as educators. We teach, and then our job is to figure out, hey, what do you know? What did you learn? And if we give them more tools to show us that makes their job easier. It makes our job easier.
Yep. 100%.